So far we've learned two methods for solving quadratic equations. We've done it graphically, and then we've also solved using the zero product property, which involves factoring. There's one more way, and that's using a formula called the quadratic formula. Remember when we did this problem, solve the quadratic equation graphically, we were just looking for the roots, the zeros, and in this case they were not falling at integer values, and so we weren't able to tell by just looking at the graph. If we were to try to factor this, you'd realize that this is prime, and we can't factor it and find the roots that way. So the quadratic formula is our go-to in this situation. The formula is great because it can be used to solve any quadratic equation, no matter what. All right, so example one, we're going to do it three different ways. We're going to start off using factoring. So take a look at this. You would go ahead and replace y with 0, and then factor our trinomial. You can see that factors into x plus 4 times x plus 2. Setting each of our factors equal to 0, you can see we've got x equals negative 4 or x equals negative 2, so the zeros of our function are negative 4 and negative 2. Now if we were to graph this, what if we were to graph it by hand if we didn't have Desmos? There are two ways that we could figure out the value of our vertex, the ordered pair for our vertex. The first way is using what we learned way back at the beginning, the opposite of b over 2a. We can plug in the values and into the opposite of b over 2a and simplify and get x equals negative 3. But the way we learned recently was to look at the two roots and split the difference in between the two, find the halfway point. So halfway between negative 4 and negative 2 is negative 3. So you can see we got the same result that way. Now we're going to take negative 3 and plug it into the original equation up here, right here, and then simplify, and we get y equals negative 1. So we know the ordered pair, negative 3, negative 1, is the vertex. So right now we've got 3 points. We've got the two roots, negative 4, 0, and negative 2, 0. We know those y values because those are on the x-axis. And then we've also got our vertex, negative 3, 1. So if I put them in a table of values like this, it might be handy to get a few more points just to make sure our graph is accurate. If I go one farther to the left and one farther to the right from those points, I could take that value, the x value of negative 5, and plug it into my original equation and simplify, and I get y equals 3. Well, I know that a parabola is symmetric, so if I go one to the left and I get a value of 3, if I go one to the right of the points that I have so far, then I would also get a value of 3. So I can fill in those values into my table of values and then go ahead and graph it by hand. It's not beautiful, but it gives a pretty accurate description of the parabola right there. All right, so those are two methods. Now we're going to try the third method. So we're going to be using this formula, and I'm going to introduce it right now. So given our standard form equation of a quadratic, y equals ax squared plus bx plus c, I've color-coded a, b, and c for you. The formula is right here. Now it looks big and crazy, but it's not really so bad. It's actually a rearrangement of that equation solving for x. It's a little bit complicated. We're not going to go through how that's done here. But what you just need to realize is that here's a formula. If you plug in the a, b, and c values, you will end up with the value of the root, the x value of the x-intercepts. Now, you might not recognize the symbol in the middle of it there, the plus minus. What that is showing us is that this is actually two values, that there is one version using a plus and one version using a minus. And rather than do all of that simplifying with a plus and then again doing all the simplifying with a minus, what we do is we do most of our simplifying with the plus minus in there, and then right at the very end we split it out into the plus and the minus versions. It just cuts down on the amount of work. So we're going to go back to example 1. We've got our formula there up in the right. So I'm going to first rewrite my quadratic equation with the a, b, and c values. And be careful that you use the sign to the left of the coefficient or to the left of the constant to make sure that you're using the proper positive or negative that goes with that number. All right, so now we're going to go ahead and plug it in. So the first thing we do is we write x equals and a humongous fraction bar. We get ready to go one step at a time. So the first piece of it is the opposite of b. The opposite is part of the formula. So as I am often doing, I'm giving you some advice about how to write it. So I definitely do this every time. I write the opposite and then I put a set of parentheses. And then it helps me to keep track of what's supposed to be positive and what's supposed to be negative. So then I fill in the b value inside my parentheses, which is 6. And then we write that little plus minus, and then we write a big radical sign. Okay, big square root sign, and we want it to be long because there's a lot of stuff that needs to be under it, and we want to make sure it's completely on top. The line goes on top of everything that's supposed to be under the radical. So the very first thing is going to be b squared, the value of b squared. So again, I put parentheses, the squared, and then I fill in my b value. And then the rest of the formula underneath that radical is minus 4, that's part of the formula, times the a value times the c value. So I do minus 4, and I put 2 sets of parentheses, and then in the first one I put in my a value, and then in my second one I put in the c value. And then the whole thing is over 2 times the a value, so I do 2 parentheses, and then I plug in the a value. So there is my nice and clean version of the whole thing. Now we're ready to simplify. All right, so we're going to take it one piece at a time. So I'm going to first start out with my x equals and my big fraction bar. And now I'm going to take the opposite of 6, and the opposite of 6 is negative 6. And then I'm going to write my plus minus, and then I'm going to write the big radical. And now I can start simplifying. Under that radical, 6 squared is going to be 36, and then I'm going to multiply negative 4 times 1 times 8, which is negative 32. And then in the denominator, 2 times 1 is 2. That's my first step for simplifying. The second step, we've got to take care of what's underneath that radical. So you can see 36 minus 32 is 4. So we write the whole thing over again, negative 6 plus or minus, change it to radical 4 over 2. Now I can simplify the square root of 4. The square root of 4 is 2 or negative 2. But because we've got that plus and minus in there, that's going to kind of take care of our 2 variations in sign. So I'm just going to rewrite square root of 4 as 2. I'm going to write x equals negative 6 plus or minus 2 over 2. So now we've got it to the 2 values in the numerator, separated by plus and minus, and the 1 value in the denominator. So we're ready now to split it up into the plus version and the minus version. So I'm first going to rewrite it negative 6 minus 2 over 2. And then I'm going to rewrite another version, negative 6 plus 2 over 2. Now, it doesn't matter which one we write first or second. We just need to have both of them, a minus version and a plus version. So now if I go ahead and simplify that first little equation up there, we get negative 8 over 2, which is equal to negative 4. Simplifying the other one, we get x equals negative 4 over 2, which comes out to be negative 2. So what we're saying, the zeros of this function are negative 4 and negative 2. And now, hey, think about what we did. Remember when we factored it, what did we get? Negative 4 and negative 2. So you can see this gives us exactly the same solution that we would have gotten before when we were coming up with the roots of this quadratic equation. All right, let's try example 2. There's our formula. We're going to rewrite, taking it one piece at a time. So I'm going to write x equals, big fraction bar, and then I'm going to write the opposite and parentheses, and I'm going to put my value of b in there. So the opposite of negative 2. Then we're going to write plus or minus. We're going to put a big square root symbol. And under that, we're going to put b squared. So I'm going to put a set of parentheses, squared, and inside that is the b value, which is negative 2. Then my formula says minus 4 times the a value is 3, times the c value is negative 9, all over 2 times the a value is 3. So that's our formula. Now it's time to simplify. So I'm going to rewrite the whole thing, simplifying one piece at a time. So x equals the opposite of -2 is +2. Then we do plus or minus, big square root symbol. -2 squared is -2 times -2, which is +4. And then I'm going to multiply -4 times 3 times -9 is +108. And then in the denominator, 2 times 3 is 6. Next step is to go ahead and add those two values underneath the radical. 2 plus or minus the square root of 112 over 6. And I'm going to go ahead and simplify the square root of 112 into 4 square root of 7 at this point. So I get it all the way simplified, and now I'm going to split it up into two pieces. So the first step is a plus version. The second step is a minus version. Again, it doesn't matter whether you write the plus one or the minus one first or second, you're still just going to get two answers. It doesn't matter the order. All right, now in terms of dealing with that 2 plus 4 square root of 7 over 6, this one's a little bit unusual in that all the terms, the 2 on the top and the 1 on the bottom, right, the 2 and the 4 square root of 7 and the 6, they all have a common factor of 2. So I can divide out a 2 to simplify it further, so I would get 1 plus 2 square root of 7 over 3. I divided all of my outside whole values by 2. This is a simplified radical form answer. Square root of 7 can't be simplified any further. I can't do any adding in the numerator. I can't do any further dividing. So this is the answer in simplified radical form. If we were to come up with an approximate value, I would put that into the calculator and come up with about 2.097. So that's going to be crossing a little bit farther to the right from the 2. Now the other version, I'm going to do the same simplifying, dividing everything by 2, and then that's my simplified radical form. I could put that in the calculator and I'd get somewhere around -1.43. So clearly not crossing at integer values. So my answer is going to be 1 plus 2 square root of 7 over 3 and 1 minus 2 square root of 7 over 3. And I can either write them as two separate values, or I can write them with the plus or minus. Or I could write them as an approximate value in the solution set -1.43, comma 2.097. All right, example 3. We're going to do the same thing, plug it into our formula. So we have x equals the opposite of b, so the opposite of -3, plus or minus the square root of b squared, that's -3 squared, minus 4 times a, which is 1, times c, which is 8, all over 2 times a value, which is 2 times 1. When I go to simplify it, I'm going to rewrite it. The opposite of -3 is +3. When I do -3 squared, I get 9. -4 times 1 times 8 is -32. And 2 times 1 is 2. Next step is to do that subtraction under the radical. We get 3 plus or minus the square root of -23 over 2. Now, you should be realizing at this point, hey, wait a minute, we can't have a negative under the square root symbol. So that's a case where that's a problem in terms of coming up with a value. The solutions are actually imaginary numbers. And that's something you're going to be dealing with when you get to Algebra 2. But for our purpose, this is one of those cases where it's not crossing the x-axis at all. So there are no real number roots. Let's try one more. All right, now what's important when you take a look at this is you've got to make sure you know what your three terms are. So I'm going to rewrite this one as y equals x squared plus 0x minus 3, because it's important to have the x term in there so that your b value is accurate. So when we go to plug it in, x equals the opposite of b, and we see that b is 0, plus or minus the square root of b squared, which is 0 squared, minus 4ac, which is minus 4 times 1 times negative 3, all over 2a, 2 times 1. Go to simplify, we get 0. There's no such thing as the opposite of 0, so we just write it as 0, plus or minus the square root of 12 over 2. Right? 0 squared is 0. Negative 4 times 1 times negative 3 is 12 over 2. So 0 plus or minus anything, 0 is not going to be changing the value, so we just first simplify the square root of 12 into 2 square root of 3, and now I can rewrite simplifying that 0 is not going to be adding to anything like I mentioned, and then the 2 over 2 we can simplify as equivalent to 1, and so we just have plus or minus 3. So our zeros are going to be negative square root of 3, positive square root of 3, so we can write it that way, or we could write it as plus or minus square root of 3, or the decimal approximation of that, negative 1.73 and 1.73.